Hello everyone, this is Srikanth, working as the assistant professor in electrical department. In this video, I want to discuss supernode analysis. Here I have one circuit. In this circuit, we need to find out nodal voltages. So node voltages we need to find out. For this, we have some steps. For node analysis, we have some steps. Those are identify the nodes. So in this circuit, how many nodes we have? So we have like 1, 2 as well as one reference node. Then identify the node voltages. So mention the node voltages. So V1, V2 and VR. Okay. Then apply the Kcl rule. So what is the Kcl rule? At a node, at a junction, the incoming currents equal to outgoing currents or sum of currents equal to 0. So this is a rule. So you need to follow that rule and write the equations. Then solve those equations, will get the values. So these are the steps for nodal analysis. So we'll move one by one. So what is your first step? Identify the number of nodes. So how many nodes we have? I said like 3 nodes. 1, 2, 3 nodes we have. Then just mention the node voltages. How many node voltages we have? V1, V2 as well as VR. VR is V reference node, that is 0. Okay. Now then apply the Kcl rule. For Kcl rule, we require the currents. So every branch we require current. So V1 node, how many branches we have? 1, 2, 3 branches. So for 3 branches we require 3 currents. Same at V2 node, we have 1, 2, 3 branches. So for 3 branches we require 3 currents. So give the current directions. That is depending upon you. So I given here the source directions. So that is my I1 direction. And this is I2 direction, and here I have current direction here. Then here I3 direction, that same as your source direction. Then here on more direction. So I have some different directions here. Then what is your I1 value? Already that is current source. So I1 value is 1.5 amps. Directly you can write here. Then what is your I2 value? So I2 value is nothing but I have like here 6 ohms. So 6 ohms means I have resistor value. So we need to go for the voltage, means V equal to I into R. So but here I want current. So current means I equal to V by R. So what is your potential difference here? What is your voltage here in this branch? That is V1 minus VR by your resistor. That means V by R. So what is your V value here? So that is V1 minus VR. VR is 0. So V1 minus 0 by your 6 ohm resistor. Clear? Now at I3 current. So here already that is current source. What is the value I3? 3.5 amps. Directly you can write. Then I4. What is the I4 value? Again we require potential difference between those branches. That branch. So V2 minus VR. V2 minus VR is nothing but 0 by your resistor. V by R. Then what about 12 volts current here? Can you say? So we can't say that. So here we need to follow the supernode analysis. So what is our supernode analysis means? When we have ideal voltage source between 2 nodes. When we have ideal voltage source between 2 nodes, then we need to move to nodal analysis. Clear? So here for this, we need to combine V1 and V2 as a one node. So this is my node now. So V1, V2 we combined, and these 2 are my nodes, single node. You can guess, like you can write as Vn. Clear? Now can you write the equation at this potential difference? So V1 and V2 as well as 12 volts. For this we can write on potential difference equation, that is, so V1 direction like a negative, suppose you write like direction is this direction, and same 12 direction also same direction, and here reverse direction. Okay, then you can write like potential difference in this node. Potential difference in this node is V1 minus V2 plus 12 equal to 0. Okay, V1 to V2. In between we have 12 volts. So 12 volts direction same, and V1 volts direction also same, but V2 is reverse. That's why I write like V1 minus V2, V1 minus V2, then your 12 volts also same direction. with respect to V1. So plus V12. Okay. So this is supernode equation. This is your supernode equation. Clear? Now, so between V1 and V2 we have V1 minus V2 equal to minus 12. This is your supernode equation. So between two nodes I have one ideal source. So using that ideal source I have one equation. Now, so now your total node. So this is your supernode. So in this node how many incoming currents we have? So I1 is incoming and I3 also incoming. For this node, this is your total node now. For this node, I3 as well as I1 both are incoming and I2 as well as I4 both are outgoing currents. Okay, I1 and I3 both are incoming currents, I2 and I4 both are outgoing currents. So you can write the equation there. At supernode, equation is I1 minus I2. So I1 is incoming, I2 is outgoing minus I2, I3 is incoming again plus I3 and I4 is outgoing. So minus I4 equals 0. Just substitute the I values there. So what is the I1 value? 1.5 amps. And what is the I2 value? V1 by 6. And what is the I3 value? 3.5. And what is your I4 value? V2 by 3. So these are the equations. Just solve those two equations. So two values, two equations. You will get the answer. So your answer like V1 is 2 volts and V2 is 14 volts. So he has like determine the node voltages. Determine the node voltages means we have like V1 and V2 two nodes we have. So two nodes voltage is V1 as well as V2. V1 is like 2 volts and V2 is 14 volts. Okay. Any circuit, just find out the how many nodes we have. Then if you have any ideal voltage source between two nodes, then move to the supernode. Then write the equation between the nodes. That means ideal voltage source equation. Then write the nodal equations. Then find out the values. So these are the simple steps to find out the node voltages. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.